Hey everybody, welcome to my talk today. My name is Will Aid. I'm super excited to be here talking with you about the Arrow library and my experience with it, things I've learned along the way. There's a ton of great developers, speakers, users of Arrow here, and it's really an honor to be amongst them talking. So with that said, let's jump right on in and talk about Arrow for data exchange and my lessons learned integrating with the Tableau Hyper API. So I want to take you through, where my mindset was when I first started using this. Arrow kind of came in midway, a little bit towards the end. First and foremost, though, we were working backwards from the Tableau Hyper API, and I'll talk about the reasoning for that here in a couple minutes. But a little background on myself to frame the talk today. I own a small consulting company called innobi. Stands for Innovative Business Intelligence. I've been working in data for over a decade now, and that includes a lot of roles. Really started as a user of systems and worked my way backwards into the more data engineering modeling side, where I tend to stand today. But I always took that as kind of a unique experience because I had the ability to see it from both sides, right? There's a lot of times a disconnect between developers and users, and I've been fortunate enough to be in different positions to kind of bridge those gaps. I love open source data engineering, so really the secret to my consulting business is to leverage a lot of the open source tools that are out there. They're so well documented, so well built in a lot of cases. It's nice that they're free and really don't come with a lot of baggage, if you will, to be implemented at any kind of company. You can just kind of pick them up and run with them in most cases, within certain reasons and bounds. I work a lot in the apparel and footwear space, just kind of been my career to date. Of course, consulted in a lot of different industries and companies, but of my 10 plus years in data, I've probably spent 7 of them specifically in apparel and footwear. And outside of the corporate aspects of my company and consulting for large companies, I worked a lot in the open source space. Really what just started as a challenge to myself to learn the tools a little bit more deeply became a nice hobby and a passion and fun thing to work on. I worked on pandas for a few years and was a core maintainer. I've been a little bit slacking in that regards for the past couple years, but 2019, 2020, worked a lot on that library and reviewed PRs and did all that cool stuff to just make pandas a better library. I mentioned this talk today would be about Hyper. So what is Hyper? Not everyone is going to know that, but it's a tool used and created by Tableau. So Tableau is a really popular visualization tool, and now more or less an ecosystem that a lot of corporate companies will have. It's really user-friendly. You don't need a lot of technical knowledge to generate really nice looking visuals. So it's really appealing to people that just want things to look nice without having to think about coding them from the ground up. Their Hyper database is really the back end that they use to their visualization software. It's columnar and Postgres-like. I think it might even be some fork of Postgres at some point. I should also qualify this talk by mentioning that I don't have any inside knowledge of how Hyper is built. I don't want to speak on the behalf of the Tableau team that builds it. I'm just approaching this from an end user perspective, as they offer a API that you can interact with their Hyper database with. The core of it is built in C++. They also have bindings for Python, C#, and Java. Python obviously very popular in that space. And worth mentioning to frame this talk, they don't have an Arrow Flight SQL implementation. Maybe something that we can talk with them about in the future to add. But for now, we are going through that kind of standard process of starting with data that may or may not be columnar. But let's assume it is, right? If we're going to start with the pandas data frame, that's more or less columnar. And then we're going to take that and kind of transpose it during a write process to use this API to write row by row, and then Hyper stores it columnar again. So in the future, Aeroflight SQL, if you're not aware of it, definitely check out the link, read up on it. Could help with that a lot, right? It would be great to get rid of that transposing middle process where we have a source and a target that are both columnar, but we still have to go to this mindset of like row by row insertion that you see a lot in database work. If we get there in the future, that would be amazing. But today it's not quite like that, so it offers some unique challenges when you're trying to build fast and performant tooling on top of it that we'll get to in a minute. And I've included here a screen grab of Tableau's own description of what Hyper is, and a link as well. So feel free to look through their documentation to learn more about it if interested. I don't want to go too deep in code today. I'll offer a couple screen grabs though, just to frame the discussion. So this is the first example you'd come across if you wanted to write using their Hyper API. This is in Python, and excluding some of the print statements here, you can see it's a good amount of code to connect. Then you create a table, you give it some a definition, a schema, right? You're giving column names, types, and then in this case, kind of towards the bottom middle there, you see for I in range 101 loop where they're actually adding some integers to this table. Okay, so this is obviously all in Python, not using even pandas at all. So you're really taking just Python lists and adding them in. And again, doing it in this looping row by row kind of methodology. So when I looked at this and figured that a lot of people would have a use case for this tooling, because I personally did, even in my consulting projects, to be able to write Python code that could automatically generate these data extracts, I thought to myself, wow, let's start with a tabular data source like a pandas data frame, write to a tabular or a column-oriented data source like a Hyper API, and in the middle, abstract that whole transposition process of a user having to worry about doing that. So that yielded pantab, and we're still not quite to the arrow part of this talk, but just to frame this up, pantab was my first attempt at making a nice library for people to interact with the Hyper API. It's really a loop over data frame iteratables. If you want to dive into the code, it's there on GitHub, and happy to answer questions afterwards about where to look. But at the end of the day, it's really a C extension, and even though the Hyper API is written in C++, they do have a somewhat unsupported C API they provide as well that we used here. If I would do it again from scratch, maybe I would have done the whole extension in C++ to have the same tooling from start to finish. But to be honest, at the time, I didn't know C++ enough to even do that, and a C extension came kind of naturally in Python. So just talking about pros and cons of this approach, it was a quick and easy performance boost, right? This has been kind of the MO of making Python fast in the data space for the past decade. You have an API that's essentially written in Python, but all your heavy lifting and management of data is done very low level in a C extension. And of course, it was relatively easy to write this. Again, I say relatively. If you're coming from a space where you've already written some C extensions in Python, or maybe worked with Python or other tooling like that, it's definitely not easy, but again, if you've already been in that space, it's nothing like brand new at the same time. It's not a groundbreaking architecture that we set up here. But there are some disadvantages to this structure. The pandas type system comes to mind. So if you've worked with pandas enough, and really this goes back to even NumPy before it, your support for nullable integers is a little wonky, or not native, I should say, to be a little bit more fair. And it's just not like the same type system that you would see in a database, for instance. And Hyper API, the Hyper technology really is a database. So there's some massaging there to get that to work, particularly with different types and nullability. Date handling becomes a little difficult. So not to go too far into the details, but even when we're dealing with date arrays in NumPy, it's still not super easy to get that data out and transform it into, say, a date format that the Hyper API is expecting. A lot of the date libraries in NumPy, at least when this was first written, were kind of private to NumPy. So you had to do a lot to either vendor parts of the date handling you wanted, or just work around that in various ways. So that was always difficult. And then the NumPy C API isn't documented everywhere. So you're stepping through source code a lot of times, doing a lot of debugging. Again, this is an area that's always improving, of course. So even now, I think it's improved a lot since the 2.5, 3 years ago that we started on Pantab. But in any case, even with all those things improving, it still wasn't quite where things were with Arrow. And not only did I want to learn more about Arrow, but just reading up about it initially, I knew that all these cons would kind of be either completely resolved or totally mitigated using Arrow. So with that, I did create a new library called HyperArrow and matched up the technologies a little bit more closely. So Arrow is written in C++. My target Hyper API was C++. With HyperArrow, I also wrote the core of this in C++. So it made it easy to use the same tooling across all the different libraries. Talking about the type system, Arrow really has a more traditional, what you would expect type system in terms of integers, their sizes, their nullability. You have built-in date support, date time support, and just a lot of nice types that match cleanly to a database more so than you would get with pandas and NumPy. So that made things a lot easier. And again, I talked about the null handling. It really comes out of the box. There's not much more you have to do to worry about how nulls are being treated in your program when you're working with Arrow. On top of that, it was really easy to extend support for batches of data. So this is not something you'll get with pandas or in the Python space. If you have like really, really big data sets and you need to work with them incrementally, or they're just batched because you're streaming it, could be a lot of different reasons why you have batches of data. But Arrow makes it really nice because the table object abstracts all that for you for the most part. And there's a lot of batch reading mechanisms that you'll find in their Arrow API that make it so that you don't have to do anything really special, whether you're dealing with a contiguous table or something that's batched, to handle them both appropriately. So that was a really nice development experience. And then for end users, there really wasn't much that needed to change here, which was nice to see. I showed on the previous slide a code example of how Pantab worked. And now you see here what HyperArrow looks like. So we were able to really abstract it to the same kind of methodology so that if people wanted to switch from one to the other, that they wouldn't really need to relearn any kind of tooling or technology. For the most part, things would be very natural to them. So again, this was the core of HyperArrow is built in C++. And then when it came to doing a Python extension, same thing, we use C++ this time for the extension. But the extension is much less code than you'd see in something like Pantab. In fact, the extension in HyperArrow is really just one small C++ file. Whereas if you were to look at Pantab, you have a bunch of different files to handle reading, writing, type system, all that stuff. All those type conversions that you need and the heavy lifting sits in the C++ core of HyperArrow, so that if you're writing from C++ or Python, you have exactly the same language and same semantics, same usage. And then, again, Python is just like a really thin wrapper on top of that. So we went from what was previously in Pantab a Python-only tool to something that now in HyperArrow can be used in C++ and Python. A little bit closer to what you see offered by the Hyper API itself, right? I mentioned before a couple slides back, they have C++, C#, Java, and Python. Again, still not getting to all 4 of those languages here, but we're halfway there. And we're starting to add some support and tooling to different languages and open it up to more developers to use this abstraction. So one last thing that I learned was how to start writing in different languages using Arrow. So it came from, I mentioned before, I was a pandas maintainer. I obviously have done a lot in the Python space, a little bit of C, a little bit of C++. But there's obviously a ton more languages doing awesome things, right? And JavaScript is another language that comes to mind that is really popular, has a great community, great following, great tooling. But you probably don't hear as many people using JavaScript for data analysis, or even in this case, like transforming tabular data from a source to a target. I mentioned that the Hyper API did not offer a binding for JavaScript. And just as something I thought would be cool, I was like, okay, well, let's see if we can make this work. I came in with the mindset that, and incorrectly, that Arrow would just do what I was kind of doing on the Python side with JavaScript, right? They had some kind of like real deep Node API connection that was doing all the transformation between the JavaScript layer and the C++ layer. But that's when I started to learn more about IPC and how Arrow was leveraging IPC to actually make that much simpler than I thought. So with IPC, what happens here instead is now on our end in HyperArrow, we still have a very small Node API that allows us to take C++ data and write it to Hyper, right? So that part hasn't really changed much. But you see in this little process flow below, really that we're not doing a super tight connection between JavaScript and C++. And what I mean by that is, we're not implementing every method that we need in C++ and creating a new wrapper in JavaScript on top of that. Instead, what we're doing is we use the JavaScript Arrow library that's already been built. And what you could do there is call table to IPC. And that arrow.table to IPC call takes your JavaScript table and writes it to a format, whether it be a file or a stream, that you could then just pick up in C++, share the same memory, not really have to redo anything. And in C++, it can kind of reconstruct that table object for you, again, sharing the same memory pool. And then from there, steps 3 and 4, once you're in C++, the heavy lifting kind of continues. But this was really kind of huge learning for me to see how that IPC worked. And you can see that in action here at the bottom. I've added 2 extra screenshots, but on the left-hand side, we're working in Node. We're using this library and then using it to just really, again, one abstracted write to Hyper call at the bottom of that left-hand screenshot. And that write to Hyper call is taking that table, dropping it, in this case, to an IPC file that then the core C++ binding will pick up and reuse the core of the entire HyperArrow library to write tables the same way that we do whether in C++ or Python on the previous slide. So super cool to see that. I mean, this was really mind-blowing to me to be able to use this. And I think if you're a JavaScript developer and doing a lot of like front-end stuff, there's so much opportunity here to grow and see a better connection between like really popular, what we'll call like front-end visualization libraries today that may need to serialize or deserialize from columnar data sources. Arrow is really going to be monumental in driving that forward in a way that's open and standardized and used across the board. So just to recap what we've talked about so far and what I learned through this journey. The arrow type system and the null handling is awesome. So if you're coming from a pandas perspective, pandas obviously has been very influential and monumental in the data space in Python for the past decade plus, but not without its rough edges. And you see that in other libraries that it inherits from, like NumPy as well. The classic example that always comes up is the nullable integer. Just becomes difficult to work with that in pandas. And Arrow is this like really nice, clean type system that you don't have that issue. The null handling is consistent and out of the box across all the different arrays that you could work with. And again, going back to like different types of dates and timestamps, having all that in the box just makes it really easy to not have to work around as a developer. The table batch reader abstraction that I've linked to here, and I talked about this before, just helps you like not have to worry too much about how your table is structured. It could be one contiguous set of data. Maybe it's 10, 20, 50 batches. It really doesn't matter. The batch reader abstraction helps you to work with that consistently and allows your data to scale to, kind of crazy sizes that may exceed your memory or whatever it is. As long as it can be read sequentially in batches, that table batch reader has you covered and lets you work with that data. And lastly, the IPC protocol is mind-blowing. I mean, for me to see how easy it was to spin up a language like JavaScript, where I didn't even really have that much of a background in JavaScript, but it wasn't necessary. I just needed to know how to make a table in JavaScript, some really light back-end development to make it so that I could drop that table to an IPC file or an IPC stream, and then my already existing libraries in C++ could just pick up the data from there and run with it without copying, without having to do a lot of heavy lifting from one language to another. To me, that was awesome to see, and something that I think will become more and more common and kind of drive the ecosystem of Arrow going forward. So thanks for coming to my talk. Hope you've enjoyed and learned something out of this. And really happy to have you here today and look forward to hearing from you. Thanks.